So let's do some examples where we can find an implied domain. So this one here, you'll remember from Unit 2 that we have to factorise that bottom line. So if I take out common factor x, 2 times 3 on 2 is 3. So this one is a, what is it? It's a hyperbola. It's been moved 3 on 2 in the positive direction. And it looks like this. So what do we want to find? The implied domain. So it is all the numbers except for 3 on 2. You might prefer to do this algebraically and just say 2x minus 3 cannot be 0. So 2x cannot be 3. X cannot be 3 on 2. So that is what we've got here. And let's have a look at C. This is weird because I don't know what this graph looks like, but I'm going to do it algebraically. What do I know? I know that x minus 5 must be greater than or equal to 0 under the square root. I also know that 8 minus x must be greater than or equal to 0. So 8 greater than or equal to x and x greater than or equal to 5. So x is less than 8, greater than 5, so it can go from 5 to 8, square brackets included. So sometimes graphically, sometimes algebraically, you're still going to get the answer. This is something we did briefly last year, these piecewise defined functions. So what we do is we have 3 separate sections. So when x is less than 0, that's what it looks like. When x is between 0 and 1, and when x is greater than 1. Okay, so we've got some important points here. What am I going to do? I'm going to mark on -1, -2, and up here. First bit, it's a graph of minus x minus 1 anytime x is less than 0. So I know it's got a negative gradient, it's got a y-intercept of -1. It's going to look like this. This is open. And I know that when x equals 0, f of 0 for that first bit is -1. So that's this point. And I also know that when, say, x is -2, we'd get -2, 2, take away 1, 1. So it also goes through -2, 1. That's a bit dodgy, but that's about there. Get the idea. Then what have we got? The middle section here. Let's have a look at that. It's 2x minus 1 between 0 and 1. So what I'm going to do here is look at the endpoints. So for the 2x minus 1 part, I'm going to go f of 0 is -1. F of 1 is 2 minus 1, 1. So it goes through 0 minus 1. Now this is included, so I'll just colour it in. And then it goes to 1, 1. So it's like the other line that we had, except this one is a little steeper because it's a gradient of 2 and it's positive. What happens after that, after 1? So let's see what happens for the half x plus a half. If we put in 1, we get 1, so this joins on. I might put in, next of all, 2, because that's also greater than 1. That would be 1 plus 1/2, 1.5. So it also goes through 2, 1.5. So it looks like that, and that's what happens forever. So this is a piecewise defined function because there's pieces in it, and you just have to treat them separately. And when I next see you, I'll show you how to do those on a calculator. So what do we have to do? Sketch the graph. There you go. State the range of f. Well, the lowest value is down here, -1, included, and then keeps going forever. It will go up to infinity from there. So the range is -1 to infinity. Odd and even functions. Right, let's go. What have we got? An odd function is an odd number. So an odd function would be something like f of x is x cubed. That's an odd function. What would that look like? Maybe you remember, maybe you don't. X cubed looks a bit like this. It's an odd function, and what happens for odd functions is that f of minus x is equal to the minus f of x. That sounds like a bit of a riddle. Let's see what happens. So if x is, say x was 1, it's saying f of minus 1 is same as the minus f of 1. F of minus 1 here, f of 1 here. They're the same y coordinate except one is negative. So they are odd functions when this is true. And they're ones with odd powers. So even functions have an even power. So it might be something like f of x equals x to the 4. We did those, didn't we? One of our units. They look like a parabola but with a little bit of a flatter bottom. The rule for this one is that f of minus x is the same as f of x. So let's look at f of minus 1 is that, and that's the same as f of 1. Let's keep my colours consistent. F of minus 1 equals f of 1. And it's even because it has an even power. So we're going to decide with these functions in the example, and this is the last one, whether the function is even or whether it is odd. Look at that. It's a squared. I'm thinking even. What does it look like? A parabola of x squared plus 7 looks like that. So yes, it is definitely even because the values that are negative are the same as the values that are positive. X to the 4 plus x squared. Again, I'm thinking even. I can draw it on a calculator and I don't know what that looks like. So I'm going to say it's even. If I wanted to check algebraically, I could go the f of 1 is going to be 1 plus 1, which is 2. The f of minus 1 is also 1 plus 1, which is 2. So yes, definitely even.